Alright, this video is for the Blended Algebra 2 course, Unit 5, Lesson 1 notes. So in this first lesson, we're going to talk about the vertex form of a quadratic function. Alright, so what we have is it says, consider that we have a graph, ax squared plus bx plus c. That's just standard form of a quadratic. So for example, that would be a parabola that looks something like 2x squared plus 4x minus 11. Alright, just a parabola that we use like in our modeling unit last. The y-intercept is always going to be using the constant c on the end of the standard form. So as an ordered pair, we would write that as 0c, or for this specific example, 0, negative 11. The equation of the axis of symmetry we did last unit as well is x equals the opposite of b over 2a. We used that a little bit to find the vertex in our modeling unit. Then the x-coordinate of the vertex is also, it comes right from that axis of symmetry, the opposite of b over 2a. Alright, so we've done some stuff with standard form. Let's look a little bit with using this opposite of b over 2a formula, and then we'll get to the new version of a quadratic here. So it says use the formula x equals opposite of b over 2a to find the turning point. That would be the vertex of each quadratic function. So if I have x squared plus 10x minus 27, you need to know that a is the coefficient in front of the x squared, b is the number in front of the x, and c is the constant. Now to find the x value, our equation of the axis of symmetry right here, we take x equals the opposite of b, so negative 10, divided by 2 times 1. Well, negative 10 divided by 2 is negative 5. And that would be our equation of the axis of symmetry. That's going to be an x equals negative 5. The vertex of this quadratic, well, the vertex is an ordered pair. It's going to have an x and a y. The x value of the vertex is equal to the axis of symmetry. The y value we have to do a little bit of work for. We need to take this x value we just found and put it into the quadratic function for x. So I'd have in parentheses negative 5 squared plus 10 times negative 5 minus 27. Now what I would do is type that into your calculator or into Desmos to find the value. So you'd have negative 5 squared plus 10 times negative 5 minus 27. And you get negative 52. And that negative 52 is the y value. Right? Okay, now the y-intercept, remember we just said above, is always the constant on the end of standard form. So it would be 0, negative 27. Now for here, I can check my work using Desmos if I wanted to. If I typed in the function x squared plus 10x minus 27, that'll graph my parabola. So if I zoom out, let's find some of these features. We said the x-intercept was at negative 27, that's right. Our turning point is also at negative 5, negative 52, which is what we had. So we know that we did our work correctly. All right, same thing for number 2 here. We'll check using Desmos. We need to know our A, our B is negative 12, and C is 7. So to find the equation of the axis of symmetry, I use my formula, opposite of B over 2A. The opposite of negative 12 is positive 12 divided by 2 times 2. Well, that's 12 divided by 4, which equals 3. So the equation of our axis of symmetry is x equals 3. The vertex occurs when you put 3 in for x. So we have 2 times 3 squared minus 12 times 3 plus 7. Now remember, our vertex is an ordered pair. So I have the x value that I got from my axis of symmetry. The y value I get by plugging x back in. Well, use your calculator again. We'll have 2 times 3 squared minus 12 times 3 plus 7. And I get the output of negative 11 as my, y value. So that's where your vertex is. The y-intercept happens using this constant, 0, 7. And just like the last problem, if you wanted to check your work, type the original equation into Desmos. 2x squared minus 12x plus 7. Now when I graph this, I see my y-intercept is at 7, which is what we said. Turning point at 3, negative 11. All right. I'm clicking the wrong thing here. Let's talk about the new part, the vertex form. Now it says a quadratic is in standard form. That's what we were just working with when it's written as ax squared plus bx plus c. There are no parentheses in standard form. Now we have another form of a quadratic here that looks a little bit different. A times x minus h squared plus k. Looks a little goofy, but it's actually going to be really helpful and really easy to work with. This is called vertex form. It's nice because it allows us to find the turning point or the vertex of the parabola. Now I'm going to put some math notation here with letters, which might seem a little confusing at first, but once we put numbers to it, it'll make sense. But write down the notes so you have it as reference. The turning point here is going to happen at negative h, comma k. The axis of symmetry is going to happen at x equals negative h. Now, if a, the number in front of the parentheses, is greater than 0, that means positive, then the graph's going to open up. If my parabola opens up, then this turning point here is going to be a minimum. If a, the first number, is less than 0, that means negative, the graph's going to open down. Now, if my graph opens down, the turning point is a maximum. So let's put that with numbers. Let's have that make sense with a few examples here. We are going to graph all these, and you can use Desmos to help you. Okay. Now, we're going to graph x plus 3, the quantity squared, minus 4. That's the first thing we're going to do. So we'll use our parentheses, x plus 3 squared minus 4. Now, when you look at this graph, we'll make a connection about our turning point here in a second. But it says the turning point, the vertex, is at negative 3, negative 4. Now let's think about that. Negative 3, negative 4, because this is a really important connection to make with vertex form and the vertex, because part of this unit will be no calculator. The turning point, you take the opposite of the number in the parentheses. The opposite of 3 is negative 3. Then you take the same as what's outside the parentheses, negative 4. That's how I got my turning point. When I look at my graph, it looks like this is a minimum, right? It's a lowest point. I'm going to take a second before we do the rest of this. I want to sketch the graph. So in order to sketch this graph, we're going to make a table. We've done this in previous units. So go ahead and make the table here. You want to make sure that you're plotting enough points that you can see. It doesn't look like the 1 and 2 are going to work, but I could go on my table and type in, there we go, negative 3 maybe. Yeah, negative 3 will fit. Got negative 4. Yep. So it looks like, what's negative 5? Negative 5, oops, that's positive 5. Negative 5 will work as well. Negative 6. There we go. Looks like those points will all fit here. So I would start at negative 6, 5, and plot all those points. You can use your table or you can use the graph. So go ahead and hit pause or use Desmos on your own. Hit pause and plot those points. You're going to be graphing a lot of quadratic functions in this unit, so make sure that you can do that with the calculator or Desmos so that when we take away your calculator, you have an idea of how the pattern of the quadratic works. All right, now the equation of our axis of symmetry always goes through the vertex here. And the thing we need to know is that the axis of symmetry is always what the x of the vertex equals. X equals -3. It's always that x value from the vertex. It's an invisible line. The y-intercept we can get from our graph. Where do we cross the y-axis? Well, we cross the y-axis at 0, 5. Now, I can get that from my graph here. I can also get the y-intercept from looking at the table on Desmos. I look where x is 0. Or I can click on my graph and get the point there. All right, next. The roots, the x-intercepts, the zeros, means x-intercept. Well, where do I cross the x-axis? Looks like I cross the x-axis here at -5 and -1. You get that from Desmos as well. Domain, left to right. We've done domain in this class. Well, on the left of my graph is an arrow. My domain on the left, then, I would say, is going towards -infinity. And to the right, I have another arrow, which means my graph goes to positive infinity. For every single parabola, our domain is always -infinity to infinity, or all real numbers. Your graph goes on forever in the left and right direction. Now, my range is a little bit different. I need a lowest y value here. That happens at -4. So we start at -4. We're going to put a square bracket. Now at the top, I have 2 arrows, which means the range goes up to infinity. So that's the first one. Let's try another one here. X minus 7, the quantity squared, -1. Now let's use our trick for the turning point. I take the opposite of that number. So the opposite of -7 is +7, the same as the number outside. Now, I can also look at my graph to do this, but let's think here. Outside this parenthesis in front, it's positive. So that means my graph's going to open up, and I'm going to have a minimum. I also expect the axis of symmetry to be equal to the x value from the vertex. You don't have to do those things without your calculator, but it helps you to kind of understand where things are coming from, what the connections are. So let's take a second now, and let's type this new function into Desmos. You can double check your work. You should see the vertex is at 7, -1. That's what we said. We also found that this is a minimum, which is true. It's the lowest point on our graph. I want you to make a table now and find what values are going to work. Now, we know our vertex is at 7, so 2 doesn't seem to fit. 3 doesn't look good, but 4 will fit on our graph. Oops. 5 will fit. So will 6, 7, 8. Right, you gotta put in some of your numbers here. 9 and 10. So it looks like I can graph from -4 to 10. Hit pause and graph that on your paper. All right. So now I can look for my y-intercept. And, ooh, I don't see a y-intercept on my graph here. So that's where Desmos is going to help me. I go to the table. Where is x equal to 0? Well, x is equal to 0 when y equals 48. So you would have to zoom out quite a bit here to see that. If you go up, you'll see it has the point 048 is the y-intercept. So we can put that on our paper here, 048. It might not show up on your paper, but you should be able to use Desmos to find the y-intercept. The roots, the x-intercepts. Well, looks like I plotted x-intercepts at 6 and 8. And again, I can find that on Desmos by clicking on the x-intercept. Finally, the domain. Always -infinity to infinity. Because I have an arrow going out to the left forever and to the right forever. My graph's domain is all real numbers. The range, I have a lowest y value here. That occurs at -1 with a square bracket. And because my graph goes up forever, the range goes to infinity. All right, last one. Negative x minus 2 to the quantity squared plus 9. Well, my turning point, I take the opposite of what's inside the parentheses, which will be +2, the same as what's outside the parentheses. So I expect my turning point to be at 2, 9. Because there's a negative in front this time, my graph's going to open down, and that means that that turning point is a maximum. We'll double check this in a second. And the equation of the axis of symmetry is always equal to the x value from the vertex. So let's graph this and double check those three things, and then find our other features. Right. So we have the graph negative in front. X minus 2. Excuse me. Plus 9. All right. Well, let's see. Our turning point here is at 2, 9. And it is a maximum. So let's take a minute, make your table, plot all the points that are going to fit. So it looks like -2 to 2. Then we can keep going. We'll make our table go x equals 3, 4, 6. I think that'll work. So that might be our whole table that we can graph. Go ahead and hit pause, graph it, and then we'll answer the last couple of questions. All right, your graph should look like mine. We've already found the turning point at 2, 9. The invisible axis of symmetry here at x equals 2. The maximum. Now my y-intercept, I can see on my graph here, is at 0, 5. But I can also check on Desmos. I graph my my y-intercept, happens when x equals 0. 0, 5 works. My x-intercepts, where I cross the x-axis, are at -1 and 5, which I can also see on my paper. The domain, again, because I go left and right forever, my domain is all real numbers, -infinity to infinity. And then the range this time is a little bit different. On the bottom of my graph, I have arrows, which means I go down forever. So I'm going towards -infinity, and I only go up to 9. 9 gets a square bracket. There are a couple practice problems to try, very similar to these, nothing too challenging, but really make sure you understand vertex form, how to plot a parabola, and finding these features of quadratics before you move on to the next lesson.